Welcome back to our NLP class. This is part 15. In this class, we are going to study about one of the word embedding technique, cosine similarity. In our last class, we saw Euclidean distance metric to measure the similarity between documents in a given corpus. In this example, let us assume there are three documents. One is related to machine learning ML, another document is related to biomedicine, and third one is related to AI. And we will consider an example that these three documents are compared based on two words. One is word data, another word is sample. And I am going to represent these three documents in terms of vectors, numerical vector, by using these two words. Let us assume that data appeared 5000 times. Just to simplify my calculations, I am just representing 5000 as 5 here, and sample appeared 4000. Let us see. This is as 4. In biomedicine, data appeared 2 times and sample appeared 4 times, and data appeared 2 times in AI and 1 time for sample. Now, we already know that how to represent these vectors in a vector space, 2D vector space. Now, we have our 3 vectors 5, 4. This is document A and document B. Document A is machine learning, B is biomedicine, and C is A. So, our second document B is 2, 4. Document C is 2, 1. This 5 and 4 can be named as A1, A2, and here it is B1, B2, and this is C1 and C2. Now, we will project these 2D vectors into our plane, 2D plane. To see, here is my 2D plane. Just let me plot this vector A, which is 5, 4. This is 5 and this is 4, and here is my vector. This is my document A. Document A means machine learning, and second one is for vector B. Vector B is 2, 4. This is 2 and this is 4. Now, I have another vector B, and the third one is 2, 1. See, this is my third vector. So, in our previous lecture, what did we see? That how we measured the similarity between these three documents just by measuring this Euclidean distance. One way is to measure the Euclidean distance. When we measure the Euclidean distance, the distance between A and C is very high compared to A and B. So, the Euclidean distance method may say that A and B are more similar than A and C. but when you look at these documents, machine learning, biomedicine and AI, we are all pretty sure that machine learning is more related to AI than biomedicine. But Euclidean distance did not capture that information. One of the reasons is the frequency in AI is very low compared to biomedicine. This is because the document size is small for AI. Maybe the frequency of each word is very small in AI, even though it is very closer to ML. This is not captured by our previous method Euclidean, but when we apply this new methodology, which is cosine similarity, then we can capture the similarity between machine learning and AI more accurately. So, before jumping into calculating the cosine similarity, just let us try to understand what this cosine similarity means and what this vector product means. So, let us assume that in that vector space, when we say that dot product of two vectors, let us assume that there are two vectors A and B, and when we do dot product of these two vectors, it is actually multiplying the corresponding coordinates A1, A2, B1, B2. So, the dot product is equal to A1, B1 plus A2, B2. So, which represent some number, numerical value. So, when you do dot product of two vectors, it gives a numerical number. So, how do we interpret this numerical number? So, when I plot this two vectors on the space, 2D space, I have my vector A and I have my vector B, and when I multiply this vector, I get some number. That number actually represents which is equivalent to the product of these two vectors, that is norm of A, norm of B, and then the cosine angle, which is equivalent to A dot B is equal to norm of this vector and norm of this vector B and cosine theta. What is this cosine theta? The theta represents the angle between A and B. So, what happens when two documents are very similar or just opposite? There is no similarity between the document A and B. What happens with respect to the angle theta? So, let us assume that there is another example, that just simply a single vector on this xy plane. This is vector A and this is theta. So, when we project this vector A on this x axis, this is angle of projection, this theta, what happens to this theta value? Whenever this theta is equal to 0, whenever this theta is equal to 0, then the cos theta becomes 1, and in my dot product, in the previous example, let me erase this one. Whenever the theta becomes 0, then cos theta becomes 1, and then the value is very high. So, whenever this one is replaced, whenever I replace this cos theta with 1, then dot product is equal to the norms of these two vector A and B. On the other hand, let us assume that theta is equal to very high, 90 degree. When theta is 90 degree, then cos 90 is equal to 0, then the dot product A dot B becomes 0. So, it actually clearly shows that whenever this angle is very high, then these two vectors are departing apart and there were no similarity between the documents. When my two documents looks like this, my first document B is here and my second document A is here and the angle is 90 degree and the cosine theta becomes 0 and the entire value dot product would be very less. So, the intuition behind this calculation is whenever I have a very small theta and my dot product would be very high, on the other hand it would be just opposite. By using this intuition, how do we calculate our cosine theta? So, cosine theta can be computed by just rearranging this equation as A dot B and norms of A, norms of B, this is L2 norms. The L2 norms represents the Euclidean distance of a vector on this xy plane, 2D plane. So, when I calculate this cosine theta, if I end up having very small value for my cosine theta, what would happen? Yeah, so let us see with this example. So, in our given previous example, that we will calculate this cosine theta for A and B and A and C and see how this theta looks like. For my first example, that first comparison, I am going to compare the document A with B. So, here my formula looks like this: cosine theta is equal to A dot B norm of A and norm of B. What is A dot B? A dot B is equal to 5 4 2 4, just multiply this is wrong, that 5 into 2 which is 10, 16 becomes 26. And in the norm of A is equal to 5 square, 4 square, 25 plus 16 which is equal to 41. Now, my cos theta becomes 26 divided by 41, and then we need to calculate norm for the next one, B. What is the norm for B? Let me erase this portion that below. So, now I need to calculate norm for B, which is equal to, what is my B? It is 2 4, which is 2 square plus which is actually an Euclidean distance. Norm means calculating the Euclidean distance, which is 4 plus 16, this is equal to 20. Now, my cos theta is 20. So, now what is in my denominator, which is 26, and then denominator is norms of these two numbers. So, when I calculate and compute overall value, it becomes around something like 0.90 or something like this. I am not sure, maybe, yeah, it may vary. So, let us assume that this is 0.87 or something, and similarly we calculate this cos theta for between the document A and C. Similarly, I am going to calculate the cosine angle between A and C. Already I know the norms of A. Norms of A is root 41, and need to calculate norm for C, which is 2 square plus 1 square, which is root 5, and my formula for cos theta is equal to dot product of A and dot product of A and C, and then product of its norms. Then I will calculate what is A and C. Dot product A and C equal to, this A is 5,4, C is 2,1. Now, it is 10 plus 4, which is 14. The final value becomes cos theta 14 divided by, which is root 41 and then next one is root 5. Finally, it is coming around 0.97. So, when I compute this value, so when I compare these two value, the previous one, the cos theta values, we assume that it is around 0.87. So, whenever the cosine angle increases, the value of theta would get decreased. So, theta of this AC is less than theta of this AB. What it says? This document A and C are very closer compared to the document A and B. So, that means angle between A and C is smaller compared to angle between A and B. So, it says that A and C are more similar than A and B, which is not captured in our previous methodology, Euclidean methodology. So, in this class we have seen that how we can map the text into our vector space, and then how we can compare different documents. We have seen an example with only 2 words and then represented those 2 words in our 2D vector, but we can expand this calculation using computers for n dimensional vector space, and we can calculate the similarity between the documents. I hope you enjoyed this calculation, and we will see in our next class. Thank you.